Question 4 is coming from circular measure. The diagram shows a sector ABC of a circle with center A and radius 8 centimeters. The area of the sector is 16 pi over 3 centimeters squared. The point D lies on the arc BC. Find the perimeter of the segment BCD. Okay, now area of the sector is given. And we know that area of a sector is equal to a half r squared theta. But this one is given as 16 pi over 3. So meaning if I equate to this one here, our radius is given as 8, then squared, then now times the theta. So that means we can now find theta. First of all, 64 divided by 2, that will be a 32. And then this is 16 pi over 3. So meaning that theta is going to be equal to 16 pi over 3, then we divide through by 32. So that is like times 1 over 32. And of course, this one goes here 2 times. So that will be pi over 6, right? So this one will give us pi over 6. Okay, then after that, having gotten the value of this theta, we can find this straight edge BC because we know this one has 8 centimeters and also this one has 8 centimeters. Then we know this angle here. That means we can use cosine rule to find that BC. Okay. So let us now look at the cosine rule. So using cosine rule, remember cosine rule and sine rule, we use them when the triangle is not right angled. So using cosine rule, then BC is going to be equal to the square root of this 8 squared, then plus again 8 squared because we have this one, then minus 2 times 8 times 8, and then the cosine of this theta here, which is opposite to this angle, I mean to this side. And that will be pi over 6. Okay, what will this one simplify to? This is 64 plus 64, that's 128. So 128, then minus also here 128. But cosine of 30 is root 3 over 2. So this one will actually cancel with the 2. So we remain with the 64. Okay, so we have 64. Then root 3, 64 root of 3. I can leave it there exact, okay? Learn how to use these exact values. Just you just round off at the end. Now, perimeter of the segment, BCD. Perimeter, we are summing up the lengths outside the shape, right? So we are seeing arc, this arc here, BDC. Then we are also having this BC, which is the straight edge, okay? So we shall have arc length BCD, then plus the straight edge BC. Arc length is r theta, so r is 8. The theta, we have gotten it as pi over 6, right? Then plus this BC here, 128, then minus the 64 root of 3. Then we can put the whole of this in the calculator, and then we write our answer to 3 significant figures. You should know that here the calculator has to be in radians. Mine is in degrees here, so I have to convert. So we have shift, then mod, rad is 4. Then we have 8 into, we have pi out of 6. Then plus the square root of 128 minus 64 root of 3. So the answer is 8.33 to 3 significant figures. 8.33 centimeters to 3 significant figures. That is that. By the way, alternatively, you would find BC you would find BC like this. Since this one is an isosceles triangle, we can actually see that this part here is the same as this. Okay, I would divide this one into 2. You see that? So that simply implies that, of course, this one will be 90. This is a half of BC. Even this one will be a half of what? BC. Now, we have a right-angled triangle. Even this one will be, no, this one will not be 8. So we have the angle that is here is theta over 2. Okay, we shall have this one here divided by 2. So this side here is opposite and this one is hypotenuse. Remember, the two sides which are perpendicular, one is opposite, the other one is adjacent. Okay, so this is adjacent, this is opposite, then this will be hypotenuse. Now, since this is a right angled triangle, then we can use SOHCAHTOA, right? So if we can use SOHCAHTOA, now we can see that this angle, this is the side opposite and then hypotenuse. That will be sine, not so? So we shall have sine of theta over 2, actually. Theta over 2 is equal to the opposite, that is a half of BC, okay? Then divide by the hypotenuse, 8. Now, a half, these 2 will multiply with the 8 to give us a 16 in the denominator. Then when you cross multiply, BC is going to be equal to that 16, then sine of this pi over 6. Remember, theta is pi over 6. Then we divide it by 2, that will be pi over what? 12. You see that? So I can also use this one here as my BC. Okay? Now, let's check this one out. 16, then sine of pi out of 12. Okay? That is the BC. Then plus, what else? Then the BDC, the r theta, which is 8 into, we have pi, then out of 6. Okay? We get the same answer. You see that? In other words, if I take away this one here, okay, the answer I get is this one here, 4.141. How about when we say square root of 128, then minus the 64, then root of 3? Do you see that we get the same? So that is that.